Hi everyone and welcome to IB Mathology, your space for mastering IBDP mathematics with clarity and confidence. I am Pooja Chaudhary and in today's session we are going to analyze a graph of a function and how to draw sign diagram of a function. So let's start with the topic. So let's first understand x-intercepts and asymptotes. Now in x-intercept, let's take an example of this curve. Now if you look carefully in this curve, it cuts x-axis at 2 points, point A and point B. These are known as x-intercepts because they cuts x-axis, whereas this curve cuts y-axis at point C. So this C point is known as your y-intercept. Now let's move to asymptotes. So asymptotes is a straight line that constantly approaches a given curve but does not meet at any infinite distance. Let's take an example. For y is equals to 1 by x. Now in this, if I put my x value as 0, my y will always approaches towards infinity because this is y is equals to 1 upon x curve. And if I put my y value as 0, I can write it like this. X is equals to 1 upon y and my y value will approaches towards infinity. So this is the basic concept of x-intercepts and asymptotes. Now let's take an example. Let's understand how to solve this question using GDC. First, we have to type the equation minus x cube plus 7x square minus 3x minus 12. Now we'll draw the graph. You can see the graph. Now we'll press G solve and find the root of the graph or the equation. So root is minus 1.04. The second root is 1.84 and the third one is 6.20. So these are the three roots 1, 2, 3. Now let's understand how to find the y-intercept. For y-intercept, you can see it is coming as minus 12. Again press G solve. Let's check the maximum turning point. Maximum turning point is 4.441, 25.146. And the minimum turning point will be 0.225, minus 12.332. Now, as you can see, your y-intercept is minus 12. X-intercepts are already given in the video. Minimum turning point and maximum turning point of the graph are these. Now, I want you to practice this question and put the answer in the comment box. Let's understand sign diagram. They are useful when checking whether a function is above the x-axis or below the x-axis. It is a visual representation that shows the intervals where a function is positive, negative or 0. Let's understand this with the help of an example. In this, you can see there is a straight line which is passing through point 2. Let's draw the sign diagram. There are some steps to draw the sign diagram. First of all, you have to draw x-axis and mark all the points on the x-axis from which the line is cutting x-axis. Now we have to look at the straight line behavior. For all the points which are greater than 2, I am getting a positive answer. My values are increasing, so I will write plus. For all the values which are less than 2, I am getting a negative answer. So I will write minus. It means my function is getting negative value or my fx is less than 0 for all the values which are less than 2. And my function is getting all positive values or fx is greater than 0 for all the values which are greater than 2. Now, what is important here to note is there is no need to draw the curves, but representation of these positive negative signs is a must. Now let's take another example. In this, we will again draw the sign diagram using the same steps. We will draw x-axis first, mark the point -1 and 3, and now we'll observe the behavior of this curve on these points. Now as you can see that for all the values which are greater than 3, my curve is getting negative. So I can write a negative sign. For all the values which are between -1 and 3, my curve is getting positive sign. Means all the values are above x-axis. And for all the values which are less than -1, I am getting again a negative sign. So I can say that my function is less than 0 for all the values which are less than -1 and greater than 3, and my function is positive for all the values which are between -1 and 3. Let's take the example when the graph is not given to you. Instead of the graph, a function is given to you. So first step is to find out the x-intercepts of the function. So we will put all the values, all the factors equals to 0. We are getting our x-intercept, and the last one is coming as 3. So we have 3 x-intercepts. Now again draw x-axis, mark all the intercepts. Now what we can do is for all the values which are greater than 3, let's check the sign. So let us take x value as 4. We will put this x value in the function. So we are getting 4 minus 2 into 4 minus 1 upon 3 minus 4. So we are getting a negative 6 answer. Right now I am only focusing on the sign. The sign is coming as negative. Now if you put any value which is between 2 and 3, let's take 2.5. So you can check with your calculation, you will be getting a positive sign. And for all the values which are in between 1 and 2, you can take any number which comes between 1 and 2, you will be getting a negative sign by following the method which I just showed you. And for all the values which are less than 1, you will be getting a positive sign. So what we can say is our function values are positive for all the values which are less than 1 and in between 2 and 3. And my function is negative or less than 0 for all the values which are between 1 and 2 and greater than 3. So how can I write this? My fx is greater than 0 for x belongs to minus infinity to 1 union 2 to 3, and my function value is less than 0 for all x belongs to 1 to 2 union 3 to infinity. And that's a wrap on today's topic, functions part 2. In the next video, we will dive into the topic translation of function with some real IB exam style questions. If it helped you, make sure to like, subscribe and drop a comment with your questions or topic you want to cover. Have a great day. Thank you.